Welcome to the first video from Netlist Studio. So this channel is going to be a dedicated space for open source hardware, custom manufacturing tools, and deep dives into embedded systems. Today I want to talk about a new product we've created called the DUT Hub, or the Device Under Test Hub. If you ever had to flash and verify a batch of PCBs by hand, you know how time consuming that can be. The DUT Hub is an open source 4-channel automated test solution designed to fix that. In a high-end factory, they use a bed of nails fixture that usually costs thousands of dollars. For a solo dev or a small shop, it's not really an option. The DUT Hub gives you 4 independent test channels with power control and telemetry, all managed through a single USB cable. So let's get into a quick live demo before we get into the details. Okay, I'm in the terminal and I'll bring up the serial port. First, let's run the help command to see what options we have, and we'll bring up the power rails. So let's say power on. You could see all the LEDs on the board have turned on, indicating that our device under test, which is connected by those 2 wires, has been powered on. At this point, we can flash the device using our JTAG mux at the bottom, which I don't have connected. We can also measure the power consumption by running the measure command. Okay, great. At this point, we could flash the board using the JTAG mux at the bottom of the cable. Once we've done that, we could move over to the second serial port, run the help command, and see what options we have. So let's try reading a GPIO. GPIO get P409. All right, we could see it's low. And we could also read an ADC channel, which is floating at the moment. But normally these would be connected to your device under test, so you could verify different voltages and confirm that the board is functioning correctly. All right, in about 10 seconds, we verified the power and logic of the board without touching a multimeter or writing any code. Okay, let's take a look at the block diagram in the schematic. On the left side, we have our PC connected to the Raspberry Pi Pico over USB. The Raspberry Pi exposes 5 different serial ports, 1 for each device under test, and 1 for general purpose control that communicates with the Pico. So the Pico is responsible for forwarding messages to each device under test, and also controlling the JTAG mux and powering on and off the board. I chose the Raspberry Pi Pico because it has a number of USB endpoints that can be converted into USB serial ports. So this allowed me to skip adding an expensive USB to serial chip like the FTDI or other similar chips. If we take a look at one of the device testers, we can see it's a Renesas RA4M1 chip. I chose this chip because it has a wide input voltage of 1.8 to 5 volts. That's important because it gives us flexibility in terms of the types of devices we can test. As long as your device I/O can handle 1.8 to 5 volts, you're good to go without any level shifters required. Okay, that's pretty much it for the hardware design. Let's take a look at how we manufactured it. Okay, here's a sped up view of me applying solder paste to the board using the wrong type of squeegee. Good enough for now. This is a stencil printer that was probably meant for t-shirts, but can be repurposed for anything, really. I like this one because it has a vacuum table and it sucks the stencil flat over the board. Here's the pick and place machine. This is a CharmHigh pick and place, really heavy duty. I find it's great for kind of small, medium workshops. Here's me calibrating the camera and the placement of the components on each reel. The machine is pretty good for 0603. That's the smallest I've gone on it so far, but for those it's pretty flawless. The feeders are Yamaha feeders and they do need to be tuned. But once you get it dialed in, they're pretty reliable. So this is the program running at full speed, just doing the common components like 0.1 microfarad capacitors. And here's me reflowing the board with a reflow oven that I built. So that's pretty much it. Here's the final product. I think it came out pretty nice. And once I get the software functioning a little bit more reliably, I'll be sure to let you know. Until then, stay tuned.